Hello, Cardinals. We are on lesson 6, getting started. We have set up 3 pages in our journal today. On page 54, we're taping in the objectives. On page 55, you're titling that vocabulary. On page 56, that's where we're doing our getting started. How would a ball move if you threw it in space? This whole lesson is going to be on Newton's third law. So as we start the getting started, the introduction today goes through the following. Running is a race that takes a lot of effort. To get a good start, you need to move from rest to running as quickly as possible. One way to do this is to launch yourself from a pair of starting blocks using your feet, like the runner in figure 6.1. Think about how the runner would fare if she were floating in space with no starting blocks or solid surface from which to start. The runner relies on interactions with other objects to move in this lesson. You explore forces involved when two objects interact. So as we go through the objectives, there are 5 objectives for this lesson. We're going to be doing those, and today's objectives involve the number 2 and number 5. Describe the forces between two interacting objects and explain the difference between action, reaction force pairs, and balance forces. We need you to set up our vocabulary, and there are 2 vocab words we want you to write down today. You want to write down Newton's third law and write down force pairs. You are going to be responsible for creating your own definitions in lesson 6. So as you read today, you're going to write your own vocabulary definitions for Newton's third law and force pairs. You also might want to draw a picture for them. So the getting started, it says, in previous lessons, you've learned about Newton's first 2 laws of motion. In this lesson, you'll learn about Newton's third law of motion. As you work, remember to follow your teacher's instruction carefully and complete all your work neatly and accurately. For step 2, you need to read the building your knowledge, action and reaction forces, and make sure you are coding as you read. It helps you remember things. And then discuss the following with your group. Write your answers in your science notebook. Discussion A and discussion B. Step 3 says place a pencil in the desk or table in front of you. Gently push the pencil so that it rolls across the surface. Write a short paragraph in your science notebook describing all the motion. Draw a force diagram showing the pencil and all the action and reaction forces. Step 4 is going to be involving you assembling a fan car as shown in figure 6.2 or below, and you're going to prepare a sketch of the fan car in your science notebook. So we're going to be using the cars from before, but now we're going to be using some battery-operated fans throughout this for this investigation tomorrow. And step 5, think about how that fan car will move if you turn on the fan. Do you think the car will move fast or slow? Will it move in one direction or will it change directions? Do you think it will keep moving or will something cause it to stop? Discuss your ideas with your group and write your predictions in your science notebook. So your to-do list for today looks like this. The first thing you want to do is finish your getting started. There are 5 steps to that, in which I just read all of them. Step 1 is a reminder to work neatly and accurately. Step 2 is to read action and reaction forces. That's in your textbook, page 84 and 85. Step 3 is to write a paragraph and force diagrams about a pencil. Step 5 is sketching that fan car, including the forces and what you think is going to happen there. And the last one is some questions and predictions about the fan car. If you get time at the end of class today, you need to read investigation 6.1, observing force pairs. That's what we'll be doing tomorrow. Good luck with your work today, Cardinals.